Hello everybody and welcome back to a live stream of the C++ user group Osnabrück, the first one after a longer pause. I think we all had online meeting fatigue and now we are back today, and I will now switch over to the slides. And let's enjoy the stream and this evening together. So before we start with the actual talk, I want to talk a little bit about some user group things. And let's start with, like the message I just said, we are back and we want to change our schedule a little bit. So before the pause we were meeting monthly, and now we want to meet every 2 months online. So this is the August meeting, and then the next meeting of the user group will be in October, and we are still looking for people who want to give talks for this October meetup and also for the ones after that. And as it was before, there are several ways to get in touch with us. We have a Twitter, or now it's called X account, at osnacpp. We read the direct messages there, so if you want to contact us via X, write us a DM there. We have a Gmail address, osnacpp@gmail.com. You can contact us there as well. And our meetup page also gives you the possibility to write us direct messages on Meetup, and there we will also read the messages and respond to you. And of course, if you know any of the Meetup organizers personally, you can also write them on their personal channels, of course. And maybe you ask yourself what kind of talks are welcome here. So it's a C++ meetup, so of course C++ talks of any kind are welcome, but usually we accept all talks which are somehow software topic related. It doesn't need to be C++. So in the last years we had also a Rust talk. We have also talks about, well, we would also like to encourage people to talk about other things like software architecture or how life in tech is. Basically anything which is somehow software related is welcome. So feel free to contact us if you have an idea for a talk. It doesn't need to be like a 60-minute or 90-minute full conference talk. It can be also half an hour, or it can be a lightning talk, and then we would gather a couple of people who would like to give lightning talks on an lightning talk event meetup then. Yeah, I hope this is interesting for you, and maybe you will contact us then. Yeah, and as is our tradition, we usually also talk about other meetups which are happening. So I had a look at what other kinds of meetups are happening online in the next time. So Meeting C++ has a lot of events on the 7th of September about are you hiring for C++. Then there's a Meeting C++ live with Kevin Henney on September the 13th. And on September the 26th, there's again a Meeting C++ job fair. So these are all interesting events which you should attend. Then there's the Rust and C++ Cardiff user group, which have a talk about the unreasonable power of combinator APIs on September 13th as well. And then the Rust meetup Linz is meeting on September 21st online. So these are the online meetups in the next time, which might be interesting for you to attend. And now we will head over to my talk about modules. And as I know, some people like to follow along with the code and the slides on their own machines, so I will be now sharing a link to the slides in the chat. Yeah, feel free to read them and to download them want to have a look at the code as well. So here is the message with the slides, and I will try to pin it to the top of the chat. Now it works. So then you can download the slides and have a look at them. And then I would say let's start. So my talk today, which should last about 60 minutes, is called Modules in 2023. So it's a little bit of a mixture of an introduction to modules as well as like a technical talk about how we can use modules today in our code base. And its first half will be a couple of slides telling you about the current state of getting modules usable in your code base, and the second part will be going through a small demo code base and try to compile it, learn about modules on the way, and I have a few backup slides then about how modules work in general. And as is tradition with this meetup, we will meet after the talk on our Jitsi server, where we can talk and discuss about the things we have seen and learned today, and I will post the link to the Jitsi server after the talk is finished. But if you have already questions in the meantime, feel free to write them in the chat. I will be looking at the chat from time to time, and then I will see what is happening. So the volume is low, so I will increase the volume a little bit. I hope it is better now. Yeah, let's see. So I hope you're hearing me better right now. I've increased the volume. I will wait a couple of seconds to see in the chat if someone is writing that the volume is better. Let's see. It's good now. That's nice to hear, because I cannot increase the volume anymore, basically. But yeah, again, feel free to write anything in the chat if something is not okay with the quality. Yeah. So before we start with the content, if you want to reach me on several other platforms, here is a link to Linktree, where's my profile, where you can find all my social media contacts if you want to chat with me about the talk or other things afterwards. Yeah. And I also like to share my research with you, and other people who are talking about modules I have learned stuff from. So this is a link of talks you should watch. There have been a lot of talks about modules in the last couple of years. Here are the ones I especially enjoyed, plus 2 ones which haven't been released yet. So there is the import CMake talk from CPP Now 2023, which will be released on YouTube in a couple of days, which is basically a newer version of the same talk from CPPCon 2022. And there is the talk from Daniela Engert from CPP 2023, where the announcement of the YouTube video came up today. And I think this is something you should also watch to get the most accurate and new module knowledge from the current state of modules. There are also a couple of articles I used to research for the talk, which I find really, really interesting. There's a blog from Kitware about CMake module support, which is basically the basis of this talk. So how to get modules running with CMake. Then Tristan Brindle has written a blog article about experimenting with modules with his Flux library, which is also an interesting approach on how to get modules running. And there's a module chapter in the C++ standard, which I also find exceptionally readable. And if you want to look at other people who use modules actively, there is in the format library, there's an implementation of using the format library as a module, which you can look at, which is also quite interesting and a good approach to get things running. But yeah, this is one of the examples I could find and I really enjoyed. Maybe if you have examples of other libraries which already use modules, you can drop them in the chat, or we can talk about that in Jitsi later. So then let's start a little bit with the theory. So what are modules anyway? So modules are a kind of separation logic in our programming of libraries and executables, and they bring a barrier and between different parts of our program and expose public interfaces to consume them. And usually they hide the actual implementation and some functionality and data which we cannot use as a consumer of the module. And a module is distinct from a package. So a package is something which I can install to use in my program, like a third-party library. And a package may consist of several modules in that sense. But in general, modules are not made, at least C++ modules are not made as a tool for distributing precompiled source code, but that would be something which would be like delivered by some kind of package manager. I see a question from Chicos in the chat. Is this a design pattern? And this is like a difficult question. So I think modules is like a term in software architecture, but it's not in that classical sense the design pattern. Yeah. A module is a way of using modules is a way of organizing your code. If you want to see that as a design pattern, I don't know if I would see that way. Yeah. We have modular programming in C++ already, not in the sense that we have been using modules, but we use source and header files for modularizing our code. We have header files which usually provide the public interface of things we want to use in other parts of a program, and CPP files which bring us the implementation. And this modularizes our code, and this has some advantages. Yeah, we don't have to stick our whole source code in one big file, but we can make distinctions, put it into several parts, organize it around business logic and behavior. And this is all fine, but it has some disadvantages. This is a very old textual-based method, including something is like copying, pasting, or like the compiler does something related to copying and pasting the header everywhere where we include it. It gets parsed and compiled all the time. And we can maybe have also problems with the order of our includes sometimes. And we have a question in the chat where Muhammad asks, in university we were taught classes. Are modules classes? And There's already an answer in the chat, but I will also answer it or elaborate a little bit on that. So a class is a data structure. So you bundle data and business logic into a class, and that is what you use, and you can use this, and it's also like a border of logic and data. But modules go beyond that, as Daniela wrote in the chat. Modules are a way of organizing your code, so you can put several classes and functions in a module and have then another part of your code consume that module. But we will see about that as we go along. So we have other languages which have models for a long time. We have Python, which uses like a file-based kind of modular system. So I can write Python files based on the name of these files, plus a little bit extras around that. We get modules which we can import, and then we can use the contents of these files as modules, or we have modules which are file-based. So I can import here a FIBO module, rename it as fib, and then use the fib function from this module to produce some numbers. We have also the Rust programming language, which uses like a similar model of modules, where files are interpreted as modules. They can be imported and then used, and they bring order and distinction into our code by bundling things and data and logic which go together in the same module. There are also much older languages which support modules like Fortran. So if you see this picture here, I took it from the Kitware blog article about using modules with CMake and C++ today, because the way CMake and Ninja work with modules in C++ is very much related to how modules in Fortran are handled. As you can see here, a module math is defined, which contains a function, and then there's a program which can use this math module. And this has been around for a long time. This has also been supported for CMake for a longer time. And basically similar mechanisms for compiling and using modules in C++ are employed as for Fortran. So how can we build modules today? Or can we work with C++ modules today? There are several ways. And the interesting thing here is that modules in C++ are a feature which not only requires compiler support, but to some extent, if you want to use it efficiently, it requires also build system support. Of course, you can always compile your code manually on the command line or with some shell script, but this usually doesn't scale to real-world projects. So in order to use it efficiently, we need build system support, because as we will see later, modules are defined in our C++ code, and therefore the build system needs a way to either understand our C++ code or to get information from the compiler about our C++ code in order to use this information about modules in order to build up the way our code is compiled. And MSBuild, so the Microsoft build system from Visual Studio, has support for modules for a longer time now. And what is basically newer is support for CMake, which is interesting because this brings us to more cross-platform use of modules, because Visual Studio and MSBuild and the CL compiler are usually available only on Windows, while CMake and Ninja are build systems, or meta build system and build system, which are available on a lot of platforms, which makes modules usable for a broader audience. And this is also what we will focus on in this talk this evening, so I won't show any examples from MSBuild, but I will only show things based on CMake here. And of course, there have been CMake scripts and modules written by other people also for some time now who want to support modules with CMake, but this is also not something I want to talk about today. Today I want to talk about the experimental official CMake support for modules, because this is what I find most interesting and what I find most usable for the foreseeable future if we want to use CMake. So compiler support here, I don't want to talk a long time here about compilers and numbers and what they support. There are a lot of other talks and articles which go into more detail and depth here, but let's say that the Microsoft Visual Studio compiler is or has full modules support, and that GCC and Clang are here lagging behind a bit with the support of the modules features. And now I want to get more into the practical part of the talk. So we want to build up a repository or some code with modules, compile it, see it, how it feels like, and how it is done. And in order to do that, we need some CMake variables here, because the CMake module support is currently in an experimental stage, and this means that we have to set some variables here to make these features even accessible. Today I will be using CMake 3.26, so I will set this variable here to this UI, which basically makes this experimental feature available to us. And then I can set up here this flag here, which allows a dynamic dependency feature in CMake, which then builds with Ninja and the dynamic dependency feature, and then we can use modules. And here again in the chat is a recommendation from Daniela to use MSVC 70.6 and Clang 17, which is a very good recommendation. So I will be using MSVC in the newest version today, and just before the talk I tried to compile Clang 17 on my Linux machine, but it didn't finish on time, unfortunately, so that I won't be able to show any Linux stuff today. Yeah, and also, as Daniela mentions here in the chat, the this idea which is shown here changes for every CMake version. CMake 3.27 is something which you can already download from the CMake website and use, and then you would require here another ID to activate this feature, which I really don't like. I personally would prefer that it's just a flag where you just say I want to use this experimental feature and set it to 1 or on, instead of specifying these IDs. But I'm not a CMake developer, so I have to live with what CMake gives us here. So now just like a small introduction to what CMake does here with this official module support. So as I said, modules are defined in our CPP file, and CMake and Ninja need information about the content of our CPP file in order to build the right compilation tree. So the content of the CPP file needs to be parsed and understood by the compiler, and then the compiler needs to give that information back to Ninja and CMake so that they know what to compile in what order and what modules are in what part of our code base. And there's a paper for a standardized output format for modules and their dependencies on a build system, which I linked here. And you can see an example of that on the next slide. And before I talk about that, I will look into the chat and see there's another question. What is this long number and why do you need this to activate this feature? So CMake hides experimental features behind these IDs. And if we want to use a feature from CMake which is not like officially released, but more like in an experimental status, we have to specify that to get that feature running. And you will see later when I pull up Visual Studio and use this feature, I will also get a warning by CMake that I will be using a feature which is not officially released and intended only for testing purposes. But sometimes in the future, when this has been tested a lot, then it will be an officially released CMake feature and the need to use this ID will vanish. So this is basically using bleeding edge CMake stuff, which is not out of its experimentating status right now. Yeah. Now I want to talk about this paper for standardized module output. So what this is basically a JSON file which gets emitted by the compilers for the build system to consume, and it contains information about the file which has been compiled and which modules it provides and which modules it requires in order to be compiled. And this can be then consumed by the build system in order to figure out how our files need to be compiled and in what order. Yeah. And yeah, before we start in the demo, there's things I tried out which didn't work very well. So there's a feature called header units where we can import headers as they were modules. Basically, I know this is not 100% correct, but for the sake of shortness, I will use this description here. And this is a feature which is not supported by this experimental CMake feature as of CMake 3.26. And there's an issue in the CMake bug tracker, feature tracker, where it is discussed. I tried out some other features like module implementation files, which didn't work, and the import of the standard library doesn't work out of the box for MSVC with the CMake support here. And this is also what gives you a little bit of feeling for that maybe this is still an experimental feature when not all things which should be working or could be working are actually working right now. So it's a CMake experimental feature, so it's meant for testing out and for compiler developers to see if everything is correct and to adapt their things. So officially it's not meant for any production code bases or anything. It's called an experimental feature, but this shouldn't prevent us from trying it out. And I would say it's demo time. And you can also if you want, have a look at this repository on GitHub or clone it yourself if you want. But I will also bring up now Visual Studio and show the code here, and we will also compile it. And before I start talking about the code, I would like to have some feedback if the code is readable. So I can increase the font size even more, but I hope that it is readable here. So then let's start. So as I said, we will be using CMake 3.26. I have a project which is called Modules 2023. I set here my experimental CMake API token for CMake.26, and I activate my experimental CXX module dynamic dependency feature. And this is basically all I need to set up modules here. And afterwards comes stuff which is not modules related anymore in that sense. So let's make this here a little bit smaller. And I have the feeling that my studio crashed. No, it didn't crash. Now it's working. So what I have here is a little bit of a little project which has 2 modules, and in the end I wanted to make like a replica of a small real-world project. So it will have a static library which consists of some modules. It will have like a main executable which uses these modules, and it will have a test executable with gtest for the modular for the static library, and then also consumes the modules for that. And for that, in order to have to use tests, I have enabled testing here, and I will include Google Test via the fetch content, and I make some recommended settings for Windows here and make Google Test available. I set my C++ standard to C++23 and deactivate any C++ extensions. So I think here so far is nothing really out of the ordinary except all these modules things. And I add a subdirectory for modules 2023, the folder. If I go into that CMake file, I will just add 3 subdirectories for our 3 folders. Core, which is the static library I will be building, which contains some modules. Core test, which is just the test executable for the core library, and example, which is like our main program, which consumes the static library. And I think we will have a look here in the beginning, I would say at our main executable, which is called example. So it at first glance, it doesn't look anything out of the ordinary. So it has a main function. It calls some functions which have like qualified namespaces, so say hello, say name. It creates a data structure, my point, and it calls a function print point and gives it my point. And the only thing here which we are maybe not used to, or which is out of the ordinary, that we don't have any includes here. So what we see here above, we have an include for the compare header. So, but where do our core and geometry namespaces and the functions and data structures which are in there come from? So they come from these imports. So I import core, which is a module, and I import geometry, which is a module. They are not defined anywhere here. They are defined in the core static library, and we will look in a couple of minutes in there. I can do that. Oops. I think Visual Studio put it below here when I tried something with IntelliSense here, but it's a good hint to put it above the imports. So these come from the core static library, which we'll look into in a couple of seconds or minutes. And the CMake lists.txt for the main executable looks also quite ordinary. So we have an add executable. For the example executable, it uses the main CPP, and we just link the core library into that. So here is also nothing out of the ordinary. Looking at our test executable, it looks fairly the same. We include gtest here to have our testing functionality available. We import the core library to get access to the we import the core module to get access to the functionality of the core module, and then we write a test for the calculation function from core, which is in the core namespace. We give it 5 and 6, and we expect 11 as the answer. And then we can build our tests. And also the CMake lists.txt for the test executable doesn't look special. It also has an add executable. We link here gtests main and also the core library, and then we use gtest discover test in order to populate here ctest with the tests. So without, or if we wouldn't have seen the imports here, nothing is special. The only special thing are the imports of the modules, and all the modules are here in our core library. And this is what we'll have a look at now. And here I want to start with the CMake lists.txt because this is here different than in the other cases. So I add a library core, and this is by default a static library. And now I define the target sources for my core library. And here I have to set the file set to cxx modules, which is the cxx modules types, and then I give it some files, core CPP, IO CPP, and geometry CPP. And this lets CMake knows that these CPP files need to be analyzed, parsed, however you want to call it, for modules. And we have a look at that. We will start with core CPP. So here comes the calculation function from, or here's it defined. And this is the first example here in the code base where we can see how modules work. Basically, here we export module core, which defines our core module. We have a module partition IO, which is in the IO CPP file. We import it and export it, so export import IO, which means we get access to the module partition here, which defines other functionality. We define a namespace core, and in that namespace core was a calculation function, which is also exported. And export keyword here means that this function is visible for the importer of the module. So, and this we can test, so I can now compile our code here. Hopefully nothing breaks. And for example, if I now run the core test where this calculation function is tested, this works, as you can see here, and our test pass. So this calculation function is available here, thanks to the export keyword here. If I would take the export keyword away here and would try to build our code, then you can see down here in the errors window, my Visual Studio is in German, which is unfortunately, but it basically tells us that calculation is not a member of core and calculation has not been found. And this is because if we have like a function or anything else, a class, a struct, whatever, in our module and we don't export it, it's only visible within the module. We need to export it in order to make it visible. What I can do, I don't need to put it here in front of the function. I can also put the export keyword here before the namespace and everything will work again. And while that compiles, I will look into the chat for some question. So I see a question from Roy, which has been redacted. Yeah, if the question is redacted, I cannot answer it, unfortunately. Sorry. And if I put the export here in front of the whole namespace, everything in the namespace will be exported. And as you can see here, I've named my namespace the same as I named my module. And I don't know if this has been established already as a good practice or a best practice, but I would guess so. And I do this because like a module in itself does not define a namespace. If I wouldn't have the namespace core here, the in calculation would be just in the global namespace, and then it wouldn't be visible anymore for the consumer really which function comes from which module. And I personally like to name namespaces like the module is called, because then I can know in my code, oh, the calculation function comes from the core module, because the namespace is also core. Now Roy has reformulated his question. So what happens if you remove the export keyword in line 2? Yeah, then nothing works anymore, basically. So I need to have some place where I export my module, basically to make it visible to the outside world. Then we have another question in the chat. I think this functionality, you can do it easily with dynamic symbol. Okay, I'm really sorry, but I don't understand that question really. Maybe we can talk about it later on the audio conferencing system on Jitsi. So I don't know if you mean something like DLLs or what a dynamic. I don't really know what a dynamic symbol is. Sorry. Yeah, the next part I want to show you is what's up with this export import IO here with the so-called module partition. So I don't need to put like all my code for a module in one big file. I can like do several things. I could do like a module interface unit and a module implementation unit, which doesn't work at the moment really here with CMake. And I can also do this, which is called a module partition, where I put some part of my module in another file, give it a name, and import it here and make it then also visible within this module. So if we look here into the IO CPP, what happens here is, let's start here. So here this module partition is defined. So this is exported as module core IO, and core IO is here imported and exported. So this brings this module partition together with the core module, and usually this name IO for the module partition, it's not visible to the outside world. It's for within the module to give this module partition a name. It has nothing to do with something like submodules, which you know from other programming languages. And yeah, and what I do within here, I have another namespace. I've called it core IO. I defined and exported some functions and function templates in here. The say hello function, the say name function, and the print point function template. And now we can ask ourselves, where does this point here come from, this data structure? It comes from another module, from the geometry module, and I need to import the geometry module here in order to get my geometry struct in order to be able to print it here with this function template. And now another new thing here is the include statements. So there is a modularized standard library. So in theory, I could write something like import std here, but this unfortunately doesn't work that easily with CMake at the moment. And there's another way to deal with getting access to the standard library. We can include the standard headers, but we don't include them after our module has been defined here, but we include them in the global module fragment, which is started here with the keyword module just by a semicolon. Then afterwards we can place our includes, and what this does, it basically does what an include does. It brings in the functionality, and only the functionality which we need is here available within the module and used. So for example, we need the string view and the cout here. No. It's compiled, it works. We can also have a look at the geometry module, which we have imported in the core module. So here again, a module is defined as a module with the name geometry. It has a geometry namespace, and in it we have a template for a struct, which is just a point with two members x and y, which can, for example, be printed by the print function here from the IO module partition. And if we go back to the main program, we see here that all these functions are used here in the main executable: the say hello function, the say name function, the point, and the print point function. And this all works without any huge problems. The only problems we see here is that IntelliSense is not up to the task yet and complains about the core namespace, but for some reason it does not complain about the geometry namespace. Oh, it complains, but it doesn't paint it red here for some reason. So this is also like IntelliSense support or IDE support is also in a like experimental stage, but it works, it compiles. We can also run the example exe here, and if we have a look at the code, we see here that hello world is printed out, that the same name function prints hello Hendrik, hello world, and that the print point function prints x equals 5 and y equals 10 without any problems. And for me personally, I like modules very much, and I've been following the developments there for a long time, mainly because I started my career as a Python programmer, and I was used to importing stuff and switching over to C++ and getting accustomed to this more textual based system based on includes and all these discussions. What do we put in the header? What do we put in the CPP file? What can we include where without sacrificing compile time performance? These things have been nagging me all the time, and for me, modules as they are now feel like a logical way to, let's say, organize our code, and it feels more modern than the include system. We don't have to have any more like, or getting rid of the header files feels for me like a correct decision towards a more modern system of organizing the code. And of course it's still fairly new and not everything works out of the box, but it's such a big feature that it's not to be expected to be working 100% fine in a short time. So I've been talking for about 50 minutes yet. I will just have a look in the chat again if there are any further questions. Yep. I see some questions have already been answered in the chat, and I'm very grateful for that. And I think we can go back to the slides for a couple of minutes. I don't want to talk here for a very, very long time, but I think we will make a short tour through the rest of my slides, which explain more how modules work. If the system lets me switch here, it does. So we have seen in our code module names. We've defined a module as export module and then an identifier. We can also use dots and that, so I could have defined something like, I don't know, mylib.core.something, but it's just a name. It's not like in any other programming language, for example Python or Rust, where something like submodules exist. And as I've also showed in the examples, namespaces are a distinct feature from modules, and modules don't introduce a new namespace. Other programming languages like Rust or Python, which don't know what a namespace is, there the module name is also something like a namespace, but in C++ we have to define our namespace as well if we don't want to put everything in the global namespace. I see another question in the chat from Roy. In terms of build dependencies, are module main source depend on their fragments, or can they be compiled in parallel? This is a pretty interesting question, which I don't know the answer for now. I have a guess, but I don't want to make a guess and say something which is completely wrong, to be honest. But maybe we can discuss it on the Jitsi afterwards. Maybe someone else here knows an answer to that, or we can research together. Yeah. Here again a small example of how a module could look like, with a namespace, an exported function, and another function which is not exported and then not usable from the outside. We've seen that in the code as well. Module. I want to talk. Maybe I want to talk about that again, because that is maybe the most interesting if you haven't seen modules before. So what can be exported? So we've seen variables, structs, classes, functions, namespaces, template function, template classes, concepts. And as long as they don't have internal linkage like static variables and functions or anything defined in an anonymous namespaces. And of course we cannot export parts of data structures, so we cannot write a class and export like a member function or a member variable of it. If we export a whole namespace, everything inside the namespace is exported, and we can also export a block. So here a short of example of stuff which won't work. So exporting something in an anonymous namespace won't work. Exporting a static variable won't work. And trying to export like a member variable of a struct won't work. While on the other hand, these are examples of things which can be exported, like a function template, a concept, a variable, or like a whole struct. There's a question from AB. Is it possible to import some fragments in more than one module? Okay, the was already answered in the chat. I was too slow. And here again is an example of exporting a whole namespace or exporting a whole block, which then exports everything in it. And here an example of how you would use the import keyword. So we have, in this example, a math module. We import in the algorithm module, which is totally okay. It's just another module. We try to import the math module. This is not okay. We cannot import ourselves. We define a namespace fun and try to import the module fun stuff in it. It's not okay. We cannot import from inside something which is not the global scope. Then we define a function add, and after that we try to import the more algorithms module, which is also not okay, because we try to import something here after a function has been declared, which is also not okay. This is also something I don't want to talk about today. And I think this is the end of the presentation today. I wanted to make a talk which is more like looking at it from a practical perspective. I already did like the more theoretical version of this talk in 2019, 20, I don't know anymore, at ECU. And I thought it would be like a nice experience to see this new CMake feature in action and explain modules on the way of it. And now I will look into the chat for questions for a couple of minutes, and then I will post the link to the Jitsi server where we can have like the after talk chat and discuss questions and stuff like that if you want, but I will wait a little bit here and answer questions in the chat first. What about performance when you compile a big project? So this is a question from Chicos. So if you Google around and find people who've tried out modules, most people report a speed up of compilation time with modules, which is, I would say, to be expected if you don't have to parse headers all the time anymore, for example, and other things as well. But I don't know if people like use modules already in big production code bases. So maybe depends on your definition of a big project. We might have to wait a couple of months, years before these questions can be answered. And then there's from AB, it seems to me expectation is that you can get rid of redundant computations if you design them well. This is something I would agree to, basically. Yeah. And I think it's like a more modern version. Yeah. Includes basically copy and paste, and this now is like a more modern version of dealing with dependencies in your code, which I really like, again. So before we forget that, interesting question from Mabetu. Will stud and boost become modules? There is already a stud module and a stud.compat module, which you can theoretically use as of C++23. But I didn't get that working with CMake, unfortunately. Otherwise, I would have shown it. And next remark from Daniela is counts Microsoft Office as a big project. I would count it as a very big project, but if you ask the question this way, then you know someone who works on that and they are using modules, I guess. And before I forget it, I wanted to post the link to the Jitsi here. But before that, I will answer a question from Roy, perhaps not too important. Are there conventions around file extension, CPP, CPPM, CXXM? Yeah, so I think in a lot of examples and discussions I've seen, people are using different file extensions. For modules, I've seen CPPM, I've seen IXX. I don't know if there is like a general agreement of what to use and if there should be a different file ending for that. At least CMake doesn't care what the file ending is, so I use CPP here because I'm used to that and I don't want to change that really. I mean, it could be nice to give it if you have stuff which has modules and stuff which doesn't have modules and you want to separate that, then maybe that's a good idea. I personally would like it better if it has just one file ending in my project. But I think that's, again, debatable, and it has nothing to do with functionality. That's like, it might be a choice where the industry develops, or where people agree to do something with a different ending, or maybe not, or some projects will do it another way. Mohammed asks, can I get the slides and the source code you used? Yes, you can. The link to the slides is in the pinned chat message, which should appear somewhere above. And in that is a link to the GitHub repository. And usually all my talks are open source in a way that you can easily download all the stuff and use it in any way you feel interested in. If you want to work on my code, you can fork it. If you have like ideas how to improve the code, you can also send in pull requests if you want, but it's just a small toy example, so maybe that is not really necessary. Yeah, and again, here is the link to the Jitsi server where we can all meet and talk. Now, after the talk, you don't need any account or anything. You can just click the link, give yourself a name, test your microphone and your headphones, and then maybe join the conversation if you're interested in that. Yeah. And I hope you had a good time and maybe enjoyed the talk a little bit, learned a little bit about modules on the way or how they can be used. And then we will see each other on the Jitsi server, and I will now close the live stream and head over there.